Contents. Control devices. Switches. Relays. Solenoids. Control devices are used to turn on or turn off current flow in an electrical circuit. Control devices include a variety of switches, relays, and solenoids. Control devices are needed to start, stop, or redirect current flow in an electrical circuit. Most switches require physical movement for operation, while relays and solenoids are operated with electromagnetism. Manual switches are activated by a user. Using a manual switch is a safe way for a person to interrupt the electron flow in a circuit without touching the wire. A rocker switch is a type of switch that rocks back and forth, an action where one end is raised and the other is depressed. Push switch is a switch you push to activate. In a toggle switch, the toggle handle moves or swings to make or break the circuit. In a slide switch, a slider moves linearly, slides, from position to position. A limit switch is an electromechanical device that consists of an actuator mechanically linked to a set of contacts. When an object comes into contact with the actuator, the device operates the contacts to make or break an electrical connection. A tilt switch is a type of switch that switches at a certain angle as compared to the horizon, similar to the old mercury switch. It is in fact an inclinometer with a switching output. The reed switch is an electrical switch operated by an applied magnetic field. It consists of a pair of contacts on ferrous metal reeds in a hermetically sealed glass envelope. Inside each of the mechanical switches is one or more electrical switch. Switches are described by the number of poles and throws they have. Poles refer to the number of input circuit terminals, while throws refer to the number of output circuit terminals. Push to brake switch, current flows normally, but not when the button is pushed. Push to make switch, current only flows when the button is pushed. SPST switch, single pole single throw switches are used for on-off operations and have only one switch and one way to make a connection. SPDT switch, single pole double throw switches are used for on-off operations but have two switches and two ways to make a connection. A headlamp dimmer switch is a good example of SPDT switch. The switch sends current to either the high beams or low beams of the headlight circuit. DPST switch, a double pole single throw switch is a pair of SPST switches that operate together, both are open or closed at the same time. DPDT switch, a double pole double throw switch is a pair of SPDT switches that operate together. Switching the DPDT switch controls two circuits. MPMT switch, multiple pole input, multiple throw output switches, which are also known as gang switches, have movable contacts wired in parallel. These switches move together to supply different sets of output contacts with current. An ignition switch is a good example of a multiple pole multiple throw switch. Each switch sends current from different source to different output circuits at the same time depending on position. The momentary contact switch has a spring-loaded contact that keeps it from making the circuit except when pressure is applied to the button. This is a normally open type. A horn switch is a good example of a momentary contact switch. Push the horn button and the hold sounds, release the button and the horn stops. A mercury switch is made of a sealed capsule that is partially filled with mercury. In one end of the capsule are two electrical contacts. As the switch is rotated, moved from true vertical, the mercury flows to the opposite end of the capsule with the contacts, completing the circuit. Mercury switches are often used to detect motion, such as the one used in the engine compartment on the light. A temperature-sensitive switch, also known as a bimetallic switch, usually contains a bimetal element that bends when heated to make contact completing a circuit or to break contact opening a circuit. In an engine coolant temperature switch, when the coolant reaches the temperature limit, the bimetal element bends causing the contacts in the switch to close. This completes the circuit and lights the warning indicator on the instrument panel. The time delay switch contains a bimetal strip, contacts, and a heating element. The time delay switch is normally closed. As current flows through the switch, current flows through the heating element causing it to heat, which causes the bimetal strip to bend and open the contacts. The amount of time delay before the contacts open is determined by the characteristics of the bimetal strip and the amount of heat produced by the heating element. When power to the switch is turned off, the heating element cools and the bimetal strip returns to the rest position and the contacts are closed. A common application for a time delay switch is the rear window defroster. The flasher operates basically the same as the time delay switch, except when the contacts open, current stops flowing through the heating element. This causes the heating element and bimetal strip to cool. The bimetal strip returns to the rest position which closes the contacts, allowing current to flow through the contacts and heating element again. This cycle repeats over and over until power to the flasher is eliminated. Common uses for this type of switch are the turn signals or the four-way flasher, hazard lamps. A relay is simply a remote control switch, which uses a small amount of current to control a large amount of current. A typical relay has both a control circuit and a power circuit. Relay construction contains an iron core, electromagnetic coil, and an armature, movable contact set. There are two types of relays, normally open and normally closed. A normally open NO relay has contacts that are open until the relay is energized, while a normally closed NC relay has contacts that are closed until the relay is energized. When the control circuit switch is closed, current flows to the relay and energizes the coil. The resulting magnetic field pulls the armature down, closing the contacts and allowing power to the load.
Relays are switches that are turned on and off by a small electrical current. Inside a relay is an electromagnet. When a small current energizes this electromagnet, it attracts an armature blade and closes contact points. Current that the relay is designed to switch on or off can then flow across the points. As long as the small switching current flows to the relay, the much larger current will flow through its contact points.
A solenoid is an electromagnetic switch that converts current flow into mechanical movement. As current flows through the winding, a magnetic field is created. The magnetic field will pull the movable iron core into the center of the winding. This type of solenoid is called a pulling type solenoid, as the magnetic field pulls the movable iron core into the coil. A common use for pulling solenoids are in the starting system. The starter solenoid engages the starter with the flywheel. As current flows through the winding, a magnetic field is created. These magnetic lines of force want to be as small as possible. If an iron core is placed near the coil that has current flowing through it, the magnetic field will stretch out like a rubber band, reaching out and pulling the iron bar into the center of the coil. In a push-pull type solenoid, a permanent magnet is used for the core. Since like magnetic charges repel and unlike magnetic charges attract, by changing the direction of current flow through the coil, the core is either pulled in or pushed out. A common use for this type of solenoid is on electric door locks.
One important use of a solenoid is as a mechanical switch, turned on and off by electricity. If a permanent magnet is placed within the solenoid and the current is turned on, this cylindrical core will abruptly shift to align itself with the magnetic field of the solenoid, North Pole attracting South Pole. All that is needed now is some method, such as a spring, to return the core to its original position when the current is off. A solenoid thus translates an electric current into the lateral movement of the metal core. On, off.